Hello everyone. So this is 2110 integration plus 25. So we want to look at the first question and see how best we can um, integrate this question. Let's start with question 1a. So question 1a says integrate x multiplied by e to the power x squared dx. Now in integration we have how many methods? One, extended power rule. Okay. Two, we have a substitution method. And three, we have by parts. These are the main three methods that we have. Now, if you look at this question 1a, is it extended power rule? The power is also a function. So it can't be said to have. Okay. So let's try, can it be substitution? Well, it looks like it is substitution because if we let u to be the power for e, then the derivative for u is going to be 2x dx. Now, because of the x dx, it makes it easy for us to use substitution because now we are going to have this guy written as e x squared x multiplied by dx, so that when we bring the substitution, it will be the integral of e, since x squared has been called u, we put a u there, and then x dx, if you're coming from here and you divide by 2, you have a du over 2 being equal to x dx. That means here we have du over 2. So now it becomes, I can take the 2 outside, and then I remain with du. So what does that mean? It means that we can now integrate the exponential. And what's the integral for the exponential? Of this kind, the 1 over 2 remains outside, and the integral inside it is 2e to the power u plus the constant c. That means we have half multiplied by e to the power u, which is x squared plus the constant c. Remember, I have said EU is the integral because we are integrating u with respect to u. So if the derivative is going to be 1, then when you multiply by that, you get. So that's why it's easily integrable in that manner. Okay, so this is for the first part. Interesting. Okay, let's bring part B. Let's bring part B. Part B is the integral of x squared to x power 3 plus 1 dx. You look at it again and say, okay, it's x squared, but then is an exponential to the power x to the power 3. So if we let u to be x3 plus 1, obviously du is going to be, du is going to be 3x squared dx. So if we divide by 3, we are going to have x squared dx equal to du over 3. So that from there, we can write this as 2x power 3 plus 1 multiplied by x squared dx. That is the integral of 2. We have said x squared, x power 3 plus 1 is our u. So we'll have a u here. And then we'll have a du over 3. So I put the over 3 here. That means we have 1 over 3. Now the integral of 2 u and du. Okay. So now how then do we integrate that? Now we understand very well that if you are going to differentiate 2 to the power u, the derivative of this is going to be 2 to the power u ln u. Okay, ln u u². That will be the derivative for this. So that means that, ln 2, not ln u. Sorry. So you place a ln 2 and then u². So this is the derivative for 2 to the power u. So this means that as we receive it in the integral, it will be 1 over 3, okay, 2 to the power u. The u prime is right there, so we need to do it to divide by the mean of 2 and then bracket c. Now, what up? Because now we can write this as 2 to the power u, which is x power 3 plus 1, and divide by 3 mean 2 plus c. For integration, it's very easy. When you doubt, you can do the actual integration. You can do the differentiation transformation. So if you doubt, you can get this answer and differentiate it. If you differentiate the numerator, you are going to get x squared, to be 3x squared, 2 to the power x 3 plus 1 multiplied by 2. Now it's being divided by 3, 2. So it means that this will cancel, and you remain with the question. You remain with x squared, 2x3 plus 1. So then, how do I know that now I need by parts, now I need substitution? For substitution, you are able to see the derivative of this certain part being multiplied. In this case, we have seen the derivative of the power being multiplied here with the base. So we could let the power be some u, and then see that, oh, the one thing that is being multiplied there is actually the du to that power. So it can help us to reduce or to write the exponent in that form, which is easily integrable. Okay, so take note, let u be the power, differentiate, and see if you're able to get the other thing that's being multiplied by the base. Okay, let's move next. We go to C. So coming to C, we have the integral of x plus 3 in brackets and e to the power 2x at dx. Now I need to be careful here. Here is another integral that looks like you can do substitution. But you cannot try, because if you say let u be 2x, there we are doing there, let u be 2x. And when you differentiate u, you have a 2. Now that does not give us the x. Okay? So it means that it's not a direct substitution here. We may have to do one or two things. So first, let's start by expanding. So we have x, e 2x plus 3 e 2x dx. Okay, so I'm doing this not because I could not do the by parts directly on top there. I could do the by parts on top there. But because it's possible that you may not know the by parts, at least you get a mark for integrating this piece. Because sometimes you may start fighting for marks away from the concept. So you develop some skills that can help you attract some marks. So for the first part, we use by parts. Now, under by parts, we must be a bit careful. Okay? How then do I choose which one becomes my u? Can we apply that criteria? Like where the L stands for the log, the I for the inverse tree. Okay? The A for algebra. When we say algebra, we mean the powers of x. T, tree. And then E, exponential. The exponent. Okay? So the way that word is from left, your left, when you find a combination, the left on the word, not in the question. The left in the word is what becomes your u. And your dv is on the right in the word like that. So when I come here, I have x e to the power 2x. E is the exponential. It's on the right in the word. X is the algebra, the E. I mean the A. It's on the left. So it becomes the U. So U becomes X. Quickly, once you identify the U, you differentiate it to get 1 multiplied by dx. The dv becomes the one on the right. The E 2x dx. And then the v, you integrate the dv. So we have E 2x divided by 2, because to integrate the exponential, you differentiate and divide by the delta of the power. So now, what we have for this part is a combination. Okay, the by parts, I'm integrating u dv. The answer I get is uv minus the integral of v du. Okay, so we're integrating this guy. We have already identified our u, so our u is x, and then we have e 2x over 2, which is our uv now, minus the integral of v du. V du. So we have e 2x, which is our v, over 2, of course, and our du is 1 to dx. Okay, and then plus, you can integrate that one directly, so it will be e 2x, and it will be here over 2 plus a c. Okay, so I've added a c. Not that I'm done integrating, but because I feel like I've done enough so far. The final thing is, should be the solution. So I'll have x e 2x over 2 minus e 2x over 4. Because that 2 is coming down now. When I differentiate 2x, I'll get a 2. And I multiply by the denominator. And then plus 3 E 2x over 2 plus a C. The C does not change. Because even if I have C plus C, I will get a C. Because I don't know what that C is. So as you find the C1, C2, and then you add them up, they give you a C. It's still the same thing. So that's how you do the integration. So now, okay, let's go to D. Let's go to D. Wow. What if we went direct? So before we go to C, let's come back to this one. What if we went direct? Because you notice that there'll be by parts at some point. So if I'm sure, and I know by parts, and then you go straight. Say, okay, in the red light, it looks so clear that the U is going to be x plus 3. So when I differentiate, I'll get 1 dx. And then the V is going to, the dV is going to be E 2x dx. And what will be the V? The V is going to be E 2x over 2. Let's see. If you combine them, the integral of this guy now becomes uv, that is x plus 3 e to x, of course, over 2, minus the integral of dq. So we have the integral. We put the 2 outside, e at 2x dx. What are we getting? We're getting x plus 3 over 2 e at 2x minus e 2x over 4. Let's see, which is the same thing because the previous solution had x over 2 e 2 to the power x. E power 2x plus 3 e power 2x over 2. So you could put those two together because the e over here is twice. So you still have the solution even if you went direct. So those are options that you need when going for any assessment. Okay. What about D? Now we see that D looks like it's a trick thing, but that doesn't make it difficult. We're integrating x squared cos pi x dx. Now we're talking about pi. But pi is just some angle. We don't have to do anything. It's 180. Okay? We need to know the value of cos pi. No, because it's now cos pi x. So we don't know what x is. So what we do now is we check. We do a substitution here. If we differentiate the inside of pi x, the inside of cos, which is pi x, do we get it the x squared? No. Obviously, this has to be sum by parts. It's sum by parts because it's a product. So it's sum by parts. Now, how do we check? There we say trig, algebra trig. So we are here. We have algebra trig. So it means that we let u be the algebra, the x squared. I mean that you differentiate it, you get to x. Yes. Let the v be what? Be a tree. That will be cos pi x. Yes. Then to get v, you integrate this guy. So you get sine pi x over pi. Remember to integrate, it's over pi. Okay? And then you put the two together. So we have uv, which is x squared, sine pi x over pi, minus the integral of du. So we have 2 over 5, the integral of sine pi x over the x inside here. So the over, I've already taken the over outside. So I need to put that the over part. This is x and x. Okay. So now, what do I have? I now have x squared sine pi x. So this one is already done. X squared sine pi x over pi. This one is already done. Minus. Now the integral of this. Now it's still a product. So we still need by parts. Where u is now x and du is just a dx. And dv is sine pi x. What does that mean? It means that v is negative cos pi x over pi. So now we can put things together. So we'll say, okay, the 2 over pi is already there. Then we get a uv. So uv coming from there, it will be negative x cos pi x over pi. Then minus. Okay, minus in the formula for by parts. The integral of this guy, the integral of v du. So we'll have cos pi x. Now it has a minus. So maybe let's just come back here and say a plus because now we have 2 minus. Can we do that dx? Let's carry on. Not yet done. This means that we are getting what? This is going to be x squared sine pi x over pi plus 2x cos pi x over pi squared. Okay? Minus, so it remains minus 2 over pi squared. What is the integral of cos pi x? It's sine. It's sine pi x over pi plus c. Now that over pi, let's just come back here and change the power from being 2 to being 3 because you're multiplying by a pi. So to being 3. So we have this as the final solution. So this one sine pi x, you could put them together if you want. If you don't want, it's not the past. You put them together. Let's move forward. Interesting. It's like integration is actually easier than differentiation because it's just a reverse. Differentiation is always a bit confusing because you don't know where you are going. But to integrate, you know that there is something that gave us this thing. It's a reverse process. Except that we are reversing what we don't know. But we know that there was something that gave us this thing. If it must be integrated. That's a bit about it. Yeah. Okay. So this was D. So we go to E. So E, we're integrating x in x to the power 3 dx. Can we use by parts here? I mean, can we use substitution? How? We cannot because the derivative of the x is not x. And look, there is x as a power. So let's go straight into by parts. We let u be the same in x, the power 3, and differentiate it. So we get 3 in x, the power 2, multiplied by the derivative of the x, which is 1 over x. And then the dv is now going to be x at dx. So that our v then becomes x squared over 2. So when we put them together, so we'll have x squared over 2 ln x power 3 minus 3, because now we're doing v du. So I'll put the 3 over 2, and then the integral of x squared ln x power 2 over x. Yes. What are we having? This guy and the power goes. So we're remaining with x squared over 2 ln x to the power 3 minus 3 over 2 and the integral of x ln x squared. Yes. So let's extract x ln x squared and do the integration. So say, okay, this one again, we let u be ln x squared, so that our du becomes 2 ln x 1 over x. So I can just put the x here. And then dv, this is 2x dx. And then v, it will be x squared over 2. So we come back here and say, okay, so the integral of this guy is going to be uv, that is x squared over 2 ln x squared, like this, minus the integral of what? The two 2's will cancel as I do v du, so I'll remain with the x cancelling again, so I'll just remain with x ln x. Okay. So where we are now, we are here at x squared over 2 ln x power 3 minus 3 over 2, and that is another over 2, so I'm going to say 3 over 4. Why 3 over 4? Because this 2 is being multiplied by the 2 down here. Okay, and then x squared ln x squared. Okay, and then there's a minus, and the other minus coming, so the inside becomes plus. And the integral of what? X and x dx. Then from there, we let u be x and differentiate u as dx. Then let dv, no, sorry. If we do that, we are doomed. Let's go back. Let u be the same in x, no matter how many times, and du be 1 over x. And then let dv be equal to x dx. And then the v is going to be x squared over 2. When I get to x ln x, so we're going to have x squared over 2 dx. And there's a 3 over 2 here, that doesn't include the 3 over 2 here. So it's like that. Yeah. Coming for this one. Okay. So x squared over 2 ln x. Then minus the integral of x squared over 2 multiplied by 1 over x dx. So that means, where are we? We are at x squared over 2 ln x power 3 minus 3 over 4 x squared ln x squared, and then plus 3, it will be over 4 again because of that same 2 ln x. Of course, there's x squared there. So let's start up with x squared. With x squared and then the x. And then minus, because it was a plus, so we could put a minus. Now that is just x over 2. It's x over 2, it could easily, because this whole thing here, it's just the integral of x. Very well. Yes. So when I integrate, I'll get x. I'll get x4. So first I put the 3 over 2 coming from here. And then from there, Now I bring in the x squared over 4. Now that 4 finds a 2 here. It becomes over 8. That is over 8. And then plus 7.6. That becomes over 8. So nice, right? So, wow, there's a question here that talks about creating the reduction formula, coming up with a reduction formula for some of these that are repeated. So that if we had the reduction formula for x for something and in x for something, then it just be substituting, you just be using the reduction formula, just pressing the constant, and then it keeps coming out. Okay, so follow through again because this one was quite involving. Yeah, it was quite involving. So you try to follow through and see how to happen. That's nice. The next one is f. Or f, we've talked so much about the exponentials. We had exponential. But let me need f for you to try. So you do f as an exercise. Yeah. Wow, it's so nice. Of course, you can't think of substitution because the derivative of x to the power half is not x. Okay. It is something else, so you have to use the by parts. Okay. So look, we have x e the root of x dx. So if we let u to be the root of x, then we're talking of you could do something like this. You square here and square here. You have a u squared is equal to x, right? And then you have a du, and then you have a dx. You can get now this, you can get this effect. So you have a dx to be 2u. So you could come here and change things. Instead of using by parts, you could write this as e to the power u, that's it. And then you have x. Now what is the x? X is u squared. And then you have dx, which is what? Dx is 2u and du. So the whole setup now changes. We are dealing with 2 u3 e to the power u and du. So it's like you have a question like x to the power 3 e to the power x like this. You create offset. So you can integrate, you keep reducing, let u be your x to the power. So in this case, if you're not good at other substitution, because now you need to use let v, now it will go to by parts. So you have u and v. So you can change just here, say, okay, I want to work with x, the one I'm using. So let u be equal to x. So you forget about this that you have already done. You come back with let. Now let u be equal to x. So that your question looks smart. It looks x3 ex dx to be direct. Then now you calculate. So you say, okay, let u be x3. The first time, so du is going to be what? 3x squared dx. Then of course the v remains constant. So you're going to have a 2 uv, that will be x3 e to the power x minus 3 integral x squared e to the power x. So again, let your u be x squared. Again, your u will be x until you have integrated everything in there. So I have given you this, I've given you instead of going for the by parts directly, I needed to the other part b x and the other one b e. There's a lot of might be a bit complicated. So use this approach. So you just finish up. So it's almost there. But when you find the answer, remember you had the substitution that x is equal to u squared. And that you know what your u is. The u is the root of x. So you have to bring back the answer to that original x, not the one that you have just borrowed for the sake of easy interpretation. Okay. Should we enjoy that one? So now we go to G. What's on G? So G is the integral of x squared tan inverse of x. Yes. Let's go back to Laertes. Laertes is saying log trig inverse. Okay, the inverse trig. And we have it here. So before we forget, let u be tan inverse of x. Then differentiate it quickly. Derivative of x is 1 over 1 plus x squared. Then let dv be x squared dx. So v is going to be x power 3 over 3. Then put those together. So we have ub, that will be x power 3 tan inverse of x over 3 minus x power 3 over 1 plus x squared. Integrating 1 over 3 dx. So, funny enough, then the x3 now has a higher power as compared to our denominator. So what we do, we apply long division. So x squared plus 1 into x3. That guy can be written actually as what? As x, and then we have x3 plus x. Subtract. So we get a 0 minus x. So that means that we can write this thing as x3 tan inverse of x over 3 minus 1 over 3, and then the integral of x, x, the upper one is what? Minus x over 1 plus x. Yes. This is the important inside. So I've broken it into partial fractions. And after doing that, then I now want to integrate. So we have x, meaning tan inverse of x over 3 minus x squared over 6. Why 6? Because I've placed the 2 here, divide by 2. Now that 2 multiplied by 3. So that's why it becomes 6. Okay, and then minus minus, that becomes plus. How do we integrate x over 1 plus x squared? Use substitution. Let u be the denominator, 1 plus x squared. And we arrive at the du is going to be 2x dx. So this integral is sitting like something like this. I'm going to press the 1 over 2 outside. Now it's sitting as x dx. Which is our du. Which is our du. So it's sitting as du over u. Whereas du over u is just the mean of u. What is u? U is 1 plus x squared. That's it. I'm not bothered about putting the absolute. Remember, whenever you integrate and mean comes in, you put the absolute. That is if you're not so sure of what sign is your 1 plus x squared. Now, in this case, I know x squared is positive and 1 is positive, and I'll add it. So I'll be positive by what becomes the solution. While you will be trying this thing, if you doubt that your answer might be incorrect, you can actually try to do the differentiation. To give you the question. Something interesting. Okay, so this was the whole information that we needed for question 1. I just left you with a mini exercise that is on F after giving you a hint of how you can change things from X to U and then have an easy bypass integration. So in the next class, we're going to talk about evaluating question 2. For now, this is enough.